We spend our nights scanning the sky for something strange. A signal out of place. A structure too perfect to be natural. A civilization bold enough to announce itself across the dark. We always assume the anomaly is out there, waiting to be found, somewhere beyond us, somewhere between the stars. But after decades of searching, after mapping billions of worlds and measuring the silence of a galaxy that should be full, there is a possibility we have not seriously considered. What if the anomaly is not out there? What if it is here? And what that might mean is harder to sit with than any alien signal we never received. Here is what we do not question: that we are ordinary, that somewhere in the 400 billion stars of the Milky Way, life followed the same path it followed here. Cells, complexity, consciousness, curiosity. That intelligence is a natural outcome of enough time and enough planets. It is one of the most comfortable assumptions in science. But what if the data has been quietly building a different case? What if every discovery we have made, every planet found, every habitable zone measured, every fossil of early life recovered, has actually been narrowing the window rather than widening it? The real question may not be where everyone is. It may be whether everyone was ever a reasonable expectation to begin with. To understand why this matters, you need to understand how science arrived at the assumption of our ordinariness. It started with Copernicus. Before him, the Earth was the center. After him, it was just another rock. That correction cascaded outward for 5 centuries. Our sun is average. Our galaxy is one of billions. Our solar system appears unremarkable. This principle, that we are not special, not central, not unique, became one of the strongest foundations of modern science. And it is a good foundation. It protects us from the oldest error in human thinking, mistaking our own position for the natural position of everything. But a principle is only as good as the evidence that holds it up. And the evidence, over the past several decades, has been doing something unexpected. Every time we look for life, we found the conditions for it. Water, organic chemistry, energy gradients, planetary stability, habitable zones turned out to be common. Amino acids show up in meteorites. Simple chemistry builds toward complexity almost automatically. By every early measure, the universe looked like a place that generates life as a matter of routine. And yet, the sky remains empty. Not one confirmed signal, not one detected megastructure, not one pattern in the noise that points to a mind on the other side. For 60 years, the most sensitive instruments humanity has ever built have listened, and nothing has answered. The gap between conditions for life are common and evidence of life is common has not closed. It has widened. That gap is where this episode lives, because there is a way to read that gap that most discussions of the Fermi Paradox avoid, not as a puzzle about where civilizations are hiding, but as a signal about what intelligence actually is, how often it appears, how difficult it is to produce, and what it means that we are here to ask the question at all. The math, followed carefully, leads somewhere uncomfortable, and that is where we are going. Clue 1. Life appeared on Earth almost as soon as it physically could. The planet formed roughly 4.5 billion years ago. Within the first billion years, possibly within the first few hundred million, something that could replicate itself existed in the oceans. By geological standards, the origin of life looks almost automatic, which should be encouraging. If life appears quickly wherever conditions allow, then a galaxy full of habitable worlds should be a galaxy full of living worlds. But here is the problem. Life appearing quickly does not mean intelligence appears at all. Life on Earth spent the next 3 billion years as single cells, mostly bacteria. No movement toward complexity, no clear pressure toward a nervous system, no hint of the leap that was eventually coming. The origin of life and the origin of intelligence are not one step apart. They are separated by an abyss of time and improbability that we have almost no framework for measuring. Clue 2. The major transitions in the history of life. Each one looks, in hindsight, like it had to happen. But the evolutionary record suggests they were not inevitable. The appearance of the nucleus inside cells, the emergence of multicellular organisms, the development of sexual reproduction, the origin of complex nervous systems. Each transition required very specific conditions, very specific pressures, and, by some readings of the evidence, a degree of chance that makes each one look more like a narrow escape than a logical progression. Evolutionary theorists working on what are called hard steps have noted that several of these transitions took nearly as long as the entire window of time available for complex life on Earth. Meaning, if any one of them had taken slightly longer, it would not have happened at all before the sun's increasing heat made the planet uninhabitable. We are, possibly, the product of a sequence of near misses measured in hundreds of millions of years. Clue 3. Intelligence, specifically the kind that builds tools, accumulates knowledge across generations, and eventually develops technology, appears exactly once in the 4 billion-year history of life on Earth. Not twice, not in several independent lineages, once, in one branch of one species. That is not what you would expect if intelligence were a natural endpoint. That is what you would expect if intelligence were an accident. And accidents, by definition, do not distribute evenly. Clue 4. Put these threads together and the question changes shape entirely. We started asking, where are the other civilizations? But the harder question is, what if the chain that produced us was not a path, but a lottery? What if the universe is full of worlds with life, full of oceans moving through bacterial cycles for billions of years, full of complex ecosystems that rise and fall and leave no record? And what is missing is not life, but the observer. Not the chemistry, not the biology, but the improbable, fragile, one in a galaxy accident of a mind that asks what it is looking at. There is an explanation for all of this. It feels like relief. It shouldn't. The standard reassurance goes like this. We are ordinary. Life is common. Intelligence is common. We simply have not been looking long enough, or listening hard enough, or searching the right frequencies. The universe is immense, and 60 years of SETI, the search for extraterrestrial intelligence, is nothing against the age of a galaxy. Give it time. Expand the search. The silence is not meaningful. It is just the early phase of an investigation that has barely begun. This is a serious position held by serious scientists. It is grounded in the sheer scale of what we have not yet examined. There are hundreds of billions of stars in this galaxy alone. We have surveyed a fraction of them. Our technology has real limits. Our signals have traveled only 100 light-years from Earth, a bubble so small in galactic terms that it barely registers. And even if civilizations are out there, they may not be broadcasting in ways we can detect. They may have moved beyond radio. They may be communicating through methods we have not yet conceived. The silence may be a technical problem, not an existential one. It is a satisfying answer. It is also almost certainly incomplete. Here is the detail that does not go away. The search for technosignatures, signs of civilizations advanced enough to reshape their environments, has now extended beyond listening for radio signals. Scientists have searched across galaxies for the waste heat that any sufficiently advanced civilization would produce. A civilization that has harnessed the energy of its star, even partially, should glow in the infrared. Across surveys of hundreds of thousands of galaxies, spanning billions of stars, the signal is not there. Not just quiet, statistically absent. A civilization at the scale we would expect, after billions of years of development, should be visible from here. The scale argument that we simply have not looked hard enough becomes harder to maintain when the search expands to that level. If even a small fraction of civilizations reached significant technological scale, we would expect to see evidence somewhere in the data. And there is a second problem. The assumption of our ordinariness depends on intelligence being a natural outcome of biological complexity. But the evolutionary record, read carefully, does not support that. It supports the opposite. It suggests intelligence is not the destination of life. It is the exception. A product of such specific and compounding improbabilities that its appearance may be, in the deepest sense, extraordinary. The reassurance collapses not because the universe is small, but because the path to us was narrower than comfort allows. So if that explanation fails, what remains? The most grounded interpretation of the evidence is not that civilizations are hiding, or that we are searching wrong, or that the silence is temporary. It is that the emergence of technological intelligence is genuinely rare. Rare enough that in a galaxy of hundreds of billions of stars, it may have happened only here, or only a handful of times across cosmic history. Not because life is rare, life may be common, but because the chain of transitions required to move from the first replicating molecule to a species building radio telescopes is so long, so contingent, and so easily broken at any point that its completion may be the exception rather than the rule. This is sometimes called the rare Earth hypothesis, sometimes the hard steps model, sometimes simply the recognition that the Copernican principle, applied too confidently to intelligence, may have led us to expect something the universe was never obligated to provide. If this reading is correct, we are not a typical sample from a large population. We are an outlier, perhaps the outlier. The science ends here. But the implication does not. If intelligence is genuinely rare, not just uncommon, but extraordinarily improbable, then everything we understand about our position in the universe needs to be reread. We have spent centuries removing ourselves from the center. Copernicus moved the Earth. Darwin moved humanity from its assumed throne above nature. The modern scientific worldview has been, at its core, a long project of humility. We are not special. We are not central. We are one instance among countless. But what if that project, followed too far, leads to a different error? What if the data is now pointing towards something we are culturally unprepared to accept? That intelligence, the very thing doing the removing, may be the rarest thing in the observable universe. Not the most important thing, not the most powerful thing, simply the rarest. A product of a change so improbable that most of the galaxy spent its entire history producing life that never became aware of itself. Oceans on worlds that no one named, forests that grew and collapsed and left no memory, skies full of stars that no one ever looked up to question. If humanity is the anomaly, then the silence of the universe is not a puzzle to be solved by better telescopes or longer searches. It is a description of what the universe actually produces when left to run on its own. Life, perhaps in abundance. Observers, almost never. And if that is true, then what we are, this brief, fragile, improbable arrangement of matter that has somehow become aware of its own existence, is not ordinary. It is unprecedented, which raises a question we are not sure how to carry. What does an anomaly owe to the silence it emerged from? We started here, looking outward, searching for something strange. We always assumed the mystery was out there, in the signal that never came, in the structure no telescope has found, in the civilization that should have announced itself across the dark by now. But follow the evidence back far enough, past the decades of silence and the surveys of empty galaxies, and the evolutionary record of a chain that almost broke 100 times. And the strange thing is not what is missing from the sky, it is what is sitting here, asking about it. A universe that can produce billions of years of life, ocean after ocean, world after world, and arrive at almost no one, arrived at us. We may be the only ones who will ever know it was silent.